Hey guys, welcome everybody. Thank you very much for joining today. We had about 88 registrants. Of course, as usual, I'm not expecting everybody to show up until this time. We normally expect a 30% timeout these days, 30% turnout these days. So Practical DevSecOps, as it stands, is a monthly live event where technology professionals were very passionate about what's happening in the field of security as well. DevSecOps happens to be the primary area of focus for ourselves, and automation is a key pillar of everything that we do at DevSecOps, and that's why today's talk nicely aligns with that title as well. And I've been following up with Max and Natalie for about 6 months or so. I think we got in touch earlier in the mid of this year, and finally we're glad that we're here today. And I'm not going to introduce both of the presenters myself, but I will let them do the honors themselves. So go ahead and share your screen, and let's see how it goes today.
Thank you very much. I'm just sharing my screen. Hello, everybody, and welcome to today's session with a juicy name, Head in the Clouds. And we're going to be talking to you about automating security setup and audit setup in Google Cloud. Max?
Yeah. Hey, my name is Max. I'm the engineering lead of data science and analytics platform at Babylon. And in my day-to-day job, I work quite often with the data users on solutions to how can they access the data on their own terms, while also respecting all the laws and company policies and contracts, etc.
And I'm Natalie. I work as a cloud engineer at Babylon. I oversee all of the platforms that on which our data platform runs, all of the infrastructure, both for streaming, for data lakes, for securing all of the infrastructure and providing users with the technology that they need. I love my job very much in terms of, like, I love DevOps, I love infrastructure, but also always try to teach everyone to keep security in mind and build it into their platforms head first. We both work for Babylon, and Babylon is a health tech company. We're on a mission to put accessible and affordable health service into the hands of every person on Earth. That is a pretty bold mission, and as you can imagine, we deal with loads of data, both from outside, from data sets shared on the internet, from different companies, medical stats, but also our members' data. So all of that has to be secured at all times. So our focus a lot is on building a very secure platform, but also giving our developers a possibility to work with the data that exists in our ecosystem, but only with the data that they need access to in order to do their job quickly, to innovate quickly, to iterate over products and decisions that they make. We use cloud technologies, and if you use cloud technologies, you know that there is a vast array of tools and services and APIs that you can use. And we've been saying data, data, data. So how would a data platform look in Google Cloud, for example? You might want to start with something in terms of streaming. You might want to use a streaming platform such as Kafka, or something that is provided by a cloud provider themselves. Then you will want to get the data from the streaming platform to a data lake. You might want to use Google Dataflow or any other consumer that writes data, takes data from the streaming platform and writes it into a data lake. For the data lake itself, you might decide to use BigQuery, which is a serverless, highly available, highly scalable solution for storing and analyzing massive amounts of data. Or maybe sometimes you would need something more static, like cloud storage. And once you have all of your data in those storage and analytics platforms and services, you can do whatever you want with it. You can plug in transformations such as Airflow or Cloud Composer for Google Cloud. You might use serverless functions or like Cloud Run or applications running on some sort of cloud runtime. You would want to visualize your data, so there are many tools for that. You can use Tableau or Looker or Data Studio or anything else that you wish for. Or you might even want to go into the world of ML and AI, machine learning and artificial intelligence, and plug in some pipelines into your data lake with Kubeflow, with Vertex AI, or other solutions that exist out there. The possibilities are endless. Once you have your data in this data lake, you can do whatever you want with it. But there are always obviously the concerns of security and data access and privacy and compliance with all of the regulations, if that applies to you. So we're going to talk to you about that. And with that, over to Max for the first part of the session.
Yeah, you need to take security under consideration, especially that the cloud APIs, by default, they're kind of open. And so it's up to us to make sure that whenever somebody who we don't want access to our platform doesn't get it. So in a very simple way, this is the problem that we're facing, right? There is a traffic coming at us from both sides, and we're trying to filter out the traffic that we don't want from the traffic that we want. Of course, this is nothing new. And there is a disclaimer. There is thousands of ways of doing that. So I'm not going to be talking about the best way of doing that, because that might depend a lot on your organization. I'm going to be talking about how you can do it through a technical solution. Arguably, you should not solve that only through technical solutions. There should be an education of users and other organizational measures, like processes in place to make sure that everything is working exactly as expected. But for a couple of reasons that I'm going to mention very shortly, sometimes that alone is not enough. And so I think the unique challenge that we have with our access to data is we are a global company. We operate in multiple countries, and in addition to the policies and data governance that our company would like to kind of impose on the data that we have, there's also local regulations. And so the data privacy and data protection laws that exist in every single country, they're mostly standard, but there are some differences. And then there are also the healthcare data regulations, which can vary from country to country very drastically. That means that if you want to solve some of these access issues in an educational or organizational way, you need to deal with a lot of if-then, and that might become very unwieldy very quickly. And so just a very simple example, right? A role-based access controls is not enough in that scenario. In the scenario where, for instance, I am Max, I am in UK, and I'm trying to access UK data. So I am getting the role that gives me access to the UK data, and that is all fine because I should have access to it. But one of the laws that are governing the data outside of the control of Babylon, for instance, is the data sovereignty laws, which means that the UK data, the data referring to UK people cannot be accessed outside of the country, which means that when I travel to one of our American offices, I am not legally allowed to actually transfer this data and use it on the American servers. And so role-based access controls is not necessarily enough. Of course, we can trust everybody. We can tell everybody, oh, you should just not do that. But again, with every country, the rules can be slightly different, and we don't necessarily want to make everybody keep in mind all the rules, especially that they can get quite complex. And so instead of just simple RBAC, we want to consider a greater context of the request. And so, yes, Max is an admin, but is Max in UK? Did Max finish his data security training? Is it still valid? Maybe that's a question that we want to ask before allowing access to some data. Maybe not for admin, but for other people. What data is being accessed? And so maybe some stringent laws are applicable to a health data, but they're not applicable for some other operational data. And so we might not want to impose the same strict rules for that. And how long should the access be allowed for? And so that is going to be a kind of big thing that I'm going to be talking about. You should pretty much never allow everybody to just access stuff forever. And with that, I'm going to start talking about the kind of real life examples. What you see in front of you, maybe you recognize it's a very simplified way of defining the Terraform resource. This particular one is a Google project I am member, which basically gives the member, the user Max Wasylow, which is me, a role BigQuery job user in a particular project that I didn't mention here because it's not necessary. So one of the simplest ways that you can do that if you're not doing right now, you definitely should start doing is to start expiring access for the data users, but maybe for other cloud users as well, wherever you can. Whenever hacks happen, we all know that it's usually due to a human error and not necessarily due to a cloud API failing. Not always, but in most of the cases. And so if you're doing something like this, that means that you're eliminating a lot of zombie users that might have access to data, but they don't actually need it. The thing is, if somebody needs access to data, they are going to tell you. If somebody stops needing access to data, it's very unlikely that they are going to tell you. So if your access is forever, it's just going to keep going on. And you might have a lot of people that technically, potentially can access the data, but they're not using it in their day-to-day job, which means that you have a lot of needless attack surface that you can eliminate just by doing something like this. Another thing that you could be doing to make your data more secure is, instead of giving access to raw data, this is not necessarily anything revolutionary as well, but instead of maybe copying it and processing it into a format that might be appropriate for your user, you can use BigQuery views that allow you to process this data and de-identify it kind of on the fly. That also means that you don't have to copy the data. You don't have to maintain a couple of copies and make sure that they're all in sync and so on. You can have just one copy of the data in a central location, and then the views around it, which, depending on your role, depending on who you are, what do you need the access to data for, will give you a different view into the data. In this particular case, we are creating a redacted sensitive view into some original table, where the timestamp is passed as is because it's not a sensitive information and maybe we need it for our job. Then the name is not needed, and also it's a sensitive information, so we're redacting it. We're saying no as name. We're generating some random IDs as the ID, and we're making sure that every single row that we're getting has been consented by the user with this AI learning consent type. And the last thing, and that kind of circles back to the original problem that I stated, is I am Max, I have access to UK data, but I should not have access to it from outside of UK. And so you can use context-aware access, VPC access controls, in order to specify these kind of more fine-grained conditions. You can say stuff like, in this particular case, Max Wasylow and Natalie Godec are allowed to access BigQuery, storage, and IAP tunnel Google APIs in a particular project that is not listed, because again, that's not important in this particular case. But we can access it from a certain list of trusted APIs, maybe, or maybe from particular regions. It really depends on how do you want to configure it. And by the way, all of these three examples that I've given over here, I'm going to talk about them in a more kind of practical, like live coding sense a little bit later. And so over here, this is a kind of visual breakdown of all of this. Like when you have an unauthorized client, you can have a list of identities that you just don't want to access to your project. Or on the opposite side, to make it even more secure, maybe you just have 5 people or 5 identities that you want to have access to the project, and then nobody else will be allowed access. Even if by accident you made the IAM policy very loose for some reason, it's just good to have this kind of additional layer of protection. Another thing is maybe you don't want some IPs to access your cloud APIs. That is possible as well. And then you've got the users that should have access. You give them access, and then you can define IP ranges or, again, regions that should be able to access the project, and they will be able to access it as well. And so all of that is kind of like small pieces of the puzzle. By themselves, they are not creating a solution. They're just a cool thing, maybe. But the way that you can kind of make it work in the context of your organization is by basically making the user specify a certain data access request, say in GitHub, where it can be version controlled, it can be approved, like all of that logic is kind of built in already. And so that's fairly easy. You can include links to a certain decision of why access has been granted. If you're keeping some sort of documentation of these sort of things, maybe a particular policy that allows the user access, it really depends on you. But all of that gets taken, and in your CI/CD solution of choice, whether it be Jenkins or Azure Pipelines, really anything, you are validating that input. Maybe you're enriching it a little bit. I was talking in the beginning about, does this user have a training? You can do this kind of stuff before it even reaches Terraform. You can enrich the data, then you can pass it to Terraform, and Terraform will kind of action it. It will orchestrate the resources. It will make sure that all the things that I mentioned before are kind of applied there in the cloud, and the cloud is now secure. And so let me, I've recorded the very short demo yesterday. I'm going to be talking over it, but hopefully it's going to illustrate basically in a more kind of tangential way how all of the resources that I mentioned can actually be applied, and what are they doing? How is it affecting the live cloud APIs? So let's do that right now. Hopefully you can see it very well. There's going to be 6 steps. The first step is a setup. I am not going to apply it over here live, but I've done it before I've recorded this demo. The setup is fairly simple. It consists of 2 projects, BAM Wasylow of AutoSec and BAM Wasylow of AutoSec View, with each with 2 services enabled, IAM and BigQuery. IAM because we'll need to apply permissions in this project, and BigQuery because we're going to try to access some data. The AutoSec project is going to be used for raw data. The View one is going to be used for the authorized views. And then here I'm creating a service account that I'm going to be using while I'm running some command line tools. And then I'm giving that identity browser role in the BAM Wasylow AutoSec project, just so before we apply any other roles, just so I can at least see it and I'm not getting weird errors. And then the last piece of the puzzle is creating 2 data sets, one in the AutoSec and one in the AutoSec View. They're identical, apart from the fact that the BAM Wasylow AutoSec project data set already has some raw data in it. I've copied it before I recorded this demo as well. It's a completely mocked data, but we're going to try to get access to it. And so one way maybe that we can apply the permissions, and so that's kind of the vanilla style of doing what we want to do, is to just create this IAM member like this. In the command line, you can see that I'm making a sanity check. I'm trying to list raw tables in the raw project, and I'm getting an error because I don't have permissions to do that. And so now if I apply that Terraform block that gives my identity metadata viewer permissions in the BAM Wasylow AutoSec project, I should be able to list the raw tables. So let's do it right now. That is going to take just a couple of seconds. And after that's done, I'm going to run the same command again. So list raw tables. You can see, by the way, just underneath this, what the actual full command is. I was using a makefile to make it easier. And so now I can list the data. So, I mean, that's not a surprise. I got the correct permissions. It's not necessarily anything revolutionary. But as I mentioned before, that's not necessarily the best way of doing that, because if I forgot to remove these permissions, which I've actually done yesterday, I would have them today, and I would have them maybe in a year if there is not anybody else that would realize that why does this identity have this permission if they don't need it anymore. And so a very simple thing, like I showed on a slide before, you can just add this condition. In the expression field over here, there's a CEL expression. So that's a common, I think, expression language in which you can say that the request time needs to be smaller than the 30th of October this year, which means that even if I forget about this, in 2 days, I will lose the permissions. And so even if my identity somehow will be used for malicious attacks, like I won't have these permissions anymore. And in order to get these permissions again and again, I need to kind of ask for them again and again. And so sometimes you don't want to do that because getting access might be cumbersome, but it is really better if you make the granting of access easy and then ask people to request the access over and over, because it just eliminates the zombie users. And that's just a lot better. And so I've deleted the permissions. I've applied these ones right now. And I think you can see that I can see all the schema and list the resources again. So everything is working exactly as expected. But now I want to actually get access to this data. And so over here, I'm going to give myself a BigQuery user and BigQuery data viewer permission in that project. That project is going to expire in 2 days as well. And so even though I'm getting access to raw data, I won't have this access in 2 days. And so let's just quickly test that this actually works like I'm telling you that it is going to work. So first of all, sanity check, it doesn't work right now. I do not have permissions currently to access that data, but hopefully once I apply the Terraform, any second now, it is going to give me the permissions. I'm going to run the same command, query raw data, and you can see the data over here. But again, maybe I don't need the name, maybe I don't need the surname, there's an age and then children, all of this data can be used potentially to identify a person. And maybe I don't need this particular data for my work. Maybe in my particular task, I am just trying to determine in particular age groups if people have children or don't have children. So even though the access is going to expire, this is needlessly a lot of information that is just, you can very easily fix that. And so let's go to the next step. Over here, I'm going to apply the authorized view. And so it consists of 3 steps. The first one, the kind of meat of the solution is the actual BigQuery view. And so over here, scroll up, Max. Here we go. I'm reducting the name. So I'm saying no last name, no last surname. The reason why I'm keeping them, you can just completely remove them, but to kind of keep the schema more or less the same, I can do something like this. And then instead of showing the user directly the age, I can maybe just show the user the bucket of the age. And so the user is going to be able to figure out, is the user between, below 18 or between 18 and 30 and so on and so on. And then instead of displaying how many children does a particular person have, because that could be potentially identifiable information as well. If you're the only person that's 20 children in the world, we are just interested really that if you have children or not. And so that's what I'm doing here as well. And I'm selecting it from the raw data set. And then I'm authorizing the view. So even though I myself will not have permissions to query the raw data anymore, I am giving the view a permission on my behalf to get the original data, transform it, and show it to me. And we know that it's secure just because we're kind of filtering out all the sensitive information on the fly. And then I'm giving myself permissions also in the project so I can see it. So now let's run the Terraform again. That creates all the view, creates the authorization, and gives me permission in the view project. And once that's done, I'm going to run a very quick sanity check again, just to make sure I still don't have access to the raw data, because I shouldn't. So yeah, this doesn't work right now, but now I'm going to try to query the identified data. And you can see that this is now working. I'm querying the view, and the view gives me the identified version of the data, even though I'm querying really pretty much the original data set. There is no copy made. There's no sync issues. There is no jobs running in between them that need to copy the data. All of that is kind of done, through the view. It's a very nice abstraction layer. All right, and so the last step of our journey is going to be the access controls. And so again, I'm Max, I'm in UK, but I should not be able to access the UK data if I'm somewhere else. So I'm not in UK. And so I'm going to create an access level and a service perimeter for our 2 GCP projects. I'm restricting just the BigQuery access, and I'm going to restrict it just to US. I'm in UK, but I'm restricting it to US just to show you that once we apply this, my access won't work anymore. And so I am querying the data again, just to make sure that I still can do that. I can. So let's go to the access controls folder. Let's apply the Terraform. Let's wait for this to succeed. And this can, I think, take up to half an hour. I was quite lucky yesterday. It took just a couple of seconds. I've cut out the 2 attempts. The third one, you can see that it did actually succeed. So I'm getting this VPC Service Controls error. And so now I'm going to change it back to GB, which means that my identity is the only one who can access it. And it can access this project only from UK. And now when I'm trying to access it, it's going to fail because, again, it takes a couple of minutes to succeed. But now finally, it succeeds. And so that's pretty much me. Thanks a lot. And I'm going to let Natalie take over.
And Natalie is going to try to unmute herself. Nope. Thanks, Max. That was very interesting to see how we can give fine-grained access to your resources and kind of control everything on such a low level. And now that you personally showed that you can go off and do your job and fire off some cloud requests, hopefully once you, the participants, the audience, do the same in your company, your developer teams, your end users will be able to go off and work with cloud as well. But everything that they do is a cloud API request. And every cloud API request is an event which produces a log. So can we do something with that? Can we trace what's going on in the cloud? Can we see what the users are doing, how the platform is being used? Are those resources, those controls that you've put in place really working, or are they not? And since we've seen Max do something interesting in the cloud, let's see if we can actually trace what he did. I'm in BigQuery. And I'm going to query the logs, the data access logs, and see if his service account, remember Max was using a service account to access the data. So I'm going to look for that service account in BigQuery. I'm going to tell you why BigQuery a bit later. And look, I see all of the timestamps from yesterday, the projects that he queried, it was BigQuery that he was working with. What kind of things did he do? Like, it was a job request, did the job succeed, etc., etc. And you can see that he was querying both the AutoSec project and the Vue project here. And obviously I've queried just a couple of fields in the logs, but you can see a lot more. Let me show you how. Let me show you how to set all of that up. Logs, they're everywhere. And something that you would want to do once you have set up your access controls and your security policies and all of that, you will want to set up centralized logs and potentially audit logs if you really want to have a trace of what was happening in the cloud. Google Cloud provides you with a tool to do that. It's called logging syncs. You can create a logging sync on a project level, folder, organization, and billing account level. And what that will do, that will take all of the logs from projects, from everything that's happening in a particular project, and it will forward those logs into your destination. It can be a central project that contains all of your logs. And you can stream them into logging if you just want to have all of the logs in the same place in cloud logging. You can also stream them to BigQuery, just what I showed before, to cloud storage to have them stored, or to PubSub to then plug things like Splunk and any other external supplier. Logs are sensitive data as well. We have spoken about VPC Service Controls and how you will want to protect your resources with a perimeter. So you will probably have some perimeters protecting your kind of work projects, your data projects and whatever. But logs are also sensitive data, so you will want to have a perimeter around the logs too. You will want to protect whatever APIs you use for storing the logs, because you have your employee data there, you have your IPs there, the requests. If it's BigQuery, your queries are there. So that kind of stuff really needs to be protected on the network level as well. But then it means that nothing can exit the perimeter where your projects are, and nothing can enter the perimeter where your logs are. So how do you enable the communication? How do you enable the data sharing? You might want to say, well, just put them both in the same perimeter. What's the problem? But if you have ever worked with VPC Service Controls, you will know that more often than not, you have a use case where you will have different perimeters and some projects outside of perimeters altogether because they don't need to be protected. A very common use case is when you have your runtime, so all of your kind of Kubernetes clusters and so on being in one perimeter, your workspaces where people have access to do things and fiddle with cloud infrastructures, and maybe your kind of data warehouse, which you want to protect separately as well. So yeah, like you can't just put them all in the same perimeter and be done with it. But you can configure those kind of communications separately. So we said that the logs need to exit one perimeter and enter the other. In order to allow the exiting part, you will add an egress rule. Egress, exit, outgoing communication. And what we will want to say, you will want to allow the API, the logging API, and also the APIs of your destination storage. So if you're storing your logs in BigQuery, you will want to allow BigQuery. And you can also say, only allow this to your logging project. That's it. You have allowed the communication to the data to exit your project's perimeters and go only into your logging project. On the logging storage side, on the centralized logging side, you will want to have an access level where you will allow the writing identities of each logging sync to access it. It's a similar situation with what Max was describing earlier, when you allow only a certain user to access the resources. This is the same thing. Each logging sync has a writer identity, and you will take that identity and allow it access into your logging perimeter. That's it. You have allowed your exit and your entrance on both sides, and you can configure all of that. However, if you have to do this only once, then that's fine. But if you have hundreds of projects, each of them needs to have a logging sync, and then people create projects here or there all day, every day, doing this kind of setup manually would be very, very tedious. And even automating it, if you have to do it on the project level, would be very, very tedious. So the next step that you do, you use folders. That's my suggestion for this situation, is to create top-level folders in your organization in Google Cloud that will represent your environment whichever way is better for you. For example, on the screen, you can see non-prod and prod, if your biggest concern is to separate production and non-production. Maybe you have more granular environments like UK, US, Africa, or dev staging prod. You will want to create folders for that. Or maybe you want to represent your teams in your organization. Maybe you want to have a special space for finance, a special space for analysts, and maybe developers have their own little workspace. You will create those top-level folders, pardon me. And you will instruct everybody in the organization to only create projects underneath those top-level folders. And on your side, you create the logging syncs on the folder level. You set everything up in terms of egress policies and access levels, and IAM for writing and reading the data. Done. Then every single project that gets created underneath those top-level folders will have their logs synced automatically. You don't have to worry about it ever again. And let's see how this can be actually performed. Terraform. In my GitHub, there is a Terraform GCP audited folder module. This is a Terraform module that you can use that helps you set up everything I just described. You can just give it some inputs, say that you want, for example, a BigQuery logging sync, and you want to allow a certain access level. You can also use it for a non-audited folder if you need some subfolders or something like that. You can just use the same module for everything. And the resources that it will create is, one is the access level condition for an access level of your logging perimeter, the one that we described before. It will obviously create a folder, a very easy resource. Set up an IAM. If you're syncing logs to BigQuery, you need an IAM member for BigQuery, or you can also sync to storage, and you will have the membership, the writing permissions for that storage bucket. It will create the syncs. Also, depending on the user input, you can say, I want a BigQuery logging sync, or you can say, I want a storage logging sync. It takes optional exclusion filters and filters for logs for both BigQuery and storage. And you can see that the destination will be either the storage API or BigQuery. Beware that the storage bucket and the dataset have to exist already. You have to set them up prior to using this module. And this is how you would actually use it. Here I'm creating a BigQuery dataset for my logs. I want it in the logging project. I want to call it the demo logs, and I want to store it in the EU. This is a very simple way of creating a BigQuery dataset using Terraform. And then I'm using the audited folder Terraform module from GitHub directly. You don't have to download it or anything. You can just do it that way. I want to create a demo folder, and I want to sync the logs of that demo folder into BigQuery. So I'm using the dataset I just created, and I want to exclude the Kubernetes logs because they're way too verbose. I'm also giving the logging access level name because I want to create that famous access level condition to allow the BigQuery logging sync identity to write into the logs. Now I'm going to apply this first plan and see the resources that it's trying to create. This is using Terraform 0.15.1, I believe. So we can see in the plan, it all corresponds to the Terraform resources. We're creating a data set in the required project and location, giving the access level condition, giving IAM permissions for the writer identity to write into that data set, of course. We're creating the folder. And then we are syncing to BigQuery. So the logging sync is also being created into that data set that we set up first. We have the exclusion filter, of course. We don't want Kubernetes logs. And so we're going to apply that. It will create the resources. Obviously, I have given it some values in a separate file to tell it where to go and where to create the folder in my organization. Here it's creating everything, setting everything up, just 5 resources. And if I then use the gcloud CLI to kind of check what has been configured, I can see the access level of the logging project that I was adding a condition to. We have the names in the outputs, so we can use that and your policy number of the organization. And you can see that we have 2 members. One is a demo service account that is just necessary, and the other one is actually the folder logging writer identity. So this is the access policy. We see that it's been updated, and let's see the logging sync itself. So the logging sync name, again, was given in the outputs of Terraform, and we can see that it's now syncing out to BigQuery as it was configured. And this is exactly how I was able to see what Max was doing just before in his demo. I have the exact same setup in our organization where we have top-level folders, and each of the folders syncs its logs into a centralized location in BigQuery. So when Max was doing his little commands with BigQuery, doing the data set, seeing the data, reducing it, and seeing the views, I could see all of that listed in the logs. And I suggest that you do that as well in your organization. The way it works underneath is you have your GCP org. You enable audit logging on the org level. That will mean that all of the system events, network events, data access, and policy violations will be tracked, logged, and then you can sync them into the centralized location. Then you create your top-level folders. Here you can see production folder. Under that production folder on the left side, you see several projects created. Some of them are in a VPC service perimeter. The other ones aren't. Depending on your requirements, you might want, again, to have several perimeters or have some projects outside of the perimeter. You attach the egress policies, allowing the logging API and BigQuery API to exit those perimeters. And then what that does, because you have a logging sync on the folder level, logging API will automatically track all of the logs from all of those projects in that production folder. You sync them through the logging sync using the writer identity. So the service account, the unique service account that Google creates and attaches to the logging sync. The communication in transit is always encrypted, and the data at rest is always also encrypted. And then the sync will just put all of the data into, in this example, a BigQuery dataset. I'm saying BigQuery because it just gives you access to so much insight from your logs. Like you can store it there and then just query it in a multitude of ways. And all of that can be done, can be automated through Terraform, just the way we saw before. Just group your resources and give it some inputs, and it will automatically create everything for you. Now, I want to give you some examples of why I'm saying that BigQuery is really cool. I've said, you've seen me query the logs in BigQuery and see some data about Max, but I've also said, like, you can draw insights, you can see loads of information out of it. And here are some examples, some of the queries that you can run on your data sets that contain your logs. One is you can just simply see who accessed data in production. If you have set up some new way of controlling access to your data in production, you might want to monitor how that is working and use this query. Just see the emails of people who have done some queries in the, not even BigQuery, just queries about data in a particular project. Or maybe you want to see policy violations. This is a really cool insight. You can really track who's trying to access your platform when they shouldn't, who is trying to access UK data from the US or from some other country. You can see how many times a day it happens, who's running an automated pipeline that is running somewhere that it shouldn't be running, or using an identity it shouldn't be using, and therefore causing errors. It gives you an ability to track what is going on and potentially close up any gaps, but at the same time, it gives you an ability to maybe reconfigure something that it isn't quite working for your users. Seeing the data is empowering, as much it is for your users as it is for yourself. So you can use BigQuery for that. Or you can, again, have some stats about how much your analysts are using, for example, your BigQuery data lake. You can find their the amount of queried data, because that is also in the logs. Can you imagine that Google just gives you the amount of data that has been queried in each query? And you query all of that from the data access logs again, filter by the BigQuery API. Again, you can query by different APIs depending on what you use. And I wanted to group it all by the principal email. I want to see how much each user is querying, mostly for monitoring, but also maybe for optimization reasons, if someone is maybe doing something that they shouldn't be doing, right? And out of this, you can have dashboards. you can build a dashboard based on the information in your centralized logs that will show you all of the stats over time of how your platform is used. You can do it all yourself. It takes very little time if you have some experience with the data visualization, or you can like hire your fellow analyst for a day, or someone from the marketing department, for example, to build out something that visualizes your platform usage. And how cool is that? You will really know like what's going on, who's using what, who's doing what in which environment, like depending on like any data that you have in particular in your environment. And all of the numbers here are randomly generated. Obviously, we're not showing you the real numbers that are happening in our platforms. This is just for visualization and like, demo purposes. But I personally find it really cool. You can have real insight into the usage of the infrastructures that you have built, and see what's going on. And with that, that is all from us. We also wanted to mention that we're obviously hiring. So if you want to come in and build healthcare assistants and data platforms of the future, let us know and we can take any questions if you have any.
Guys, thank you very much. That was an excellent presentation. Both of you did that so eloquently. This looked like an almost live demonstration.
Yes, we decided not to entertain demo gods and record everything.
Question to the attendees or a comment to the attendees. If you have any questions, put them in the chat, send it to everybody, or you can use the Q&A section as well. Let's wait for a few minutes. Well, in the meantime, I got some questions myself. And slide number 3, when slide number 13, when Max was presenting, there was a section where select GUID, a random generator GUID, reminded me of the GDPR when we started to anonymize data 5 years ago when I was working on a project. Can this functionality that you demonstrated, it was just a query that you were using as an example, but I'm assuming that you can also write anonymization scripts if you don't want a citizen of UK to be seeing the information of another country's citizen.
Yeah, so you can restrict that in a couple of ways, as I was mentioning in the beginning, right? It really depends how you want to do this. And if you mean there are some circumstances when you have just one table which contains rows from users from different countries. In that particular case, yeah, 100%. You could use some sort of filter expression in the view that filters out only the users of that particular country. You can even use a join like with other country, because maybe you don't have the country location in the table that you're trying to query, but you can join it with other table, filter it out based on that table, and then output to the user the information. I think there is also more advanced things that you can do with the views. You can actually register your own, I think, JavaScript, user-defined functions, and then run them from the SQL as well. So that's a BigQuery functionality. But yeah, we decided to go like fairly simple here.
Thank you. There's another question. The access rights that you are demonstrating were largely applied today with the BigQuery system. I'm assuming it's a BigQuery system, right? The Google's data platform. Can the role-based access controls, particularly with respect to the explorations and the automations that you showed, can that be expanded to other systems and other services in GCP as well?
Yeah, so the expiration date in particular, I think you can do it on every single Google API. The cell, the common expression language, it's like it has much more functionality, but there are some things that you can use with some APIs and some things that you can use with others, but the actual request time you can use with any.
Great. That should be a wrap on the Q&A. I don't see any other questions, but for now, guys, thank you very much for creating these nice demonstrations and being such a sport and a great team, both of you, to be presenting today. And for the people that have joined, we're doing these DevSecOps live events every month. So next month is going to be the last Thursday of November. In the meantime, we're also presenting at All Day DevOps Conference today, October 28th. I'm particularly presenting the evolution of a security champion. So if you're interested, check me out in another 12 to 13 hours from now. The session is being recorded, and this will be uploaded to our YouTube channel. With that, Natalie, Max, thank you very much, guys. It's been a great, and for everybody else, have a great day, good morning, good afternoon, and good night.
Thanks a lot.
Thank you for having us.
Pleasure. See you guys.